Welcome and good morning. In today's class, we will see voltage and current across an resistor, inductor, capacitor. We know that in resistor, the voltage and current are in phase. In inductor, voltage and current is having a phase angle of 90 degree, and in capacitor, we know that voltage and current is having a phase angle of 90 degree. Now let us verify that by using a simulation. To verify that, you need AC source, go to some power system, under blocks, get an AC voltage source. We are going to use only AC voltage source, we will not use AC current source. Right click it and add it. The next thing is we require resistor, and you can get your resistor from series RLC branch. Right click it and add it to your circuit diagram. Then source, resistor. The next thing you need is measurements. Go to measurements, add current measurement and add voltage measurement. The next thing we need is, we know that in AC source you have to measure the RMS value, and you can get your RMS block from sim power system, specialized technology, control and measurement, and in measurement folder you will have RMS. And again you are having RMS in DSP system toolbox. But this will not work for our SimScape. And hence don't get the RMS block from Sim DSP system toolbox. You ensure that you got your measurement from Sim power system, control measurements. Go to RMS, add it. Now let us go to our circuit. The other thing we have forgotten is power gain. For the first thing, you have to verify R, and hence you need only R. Change the branch into resistor and assign some value. You will have two voltage measurement, one across the source and one across your load. Now let us connect all our blocks. The next thing we need is display and scope. Display will give you the numerical value and scope will give you the graphical value. You need a set of display and scope for each measurement. So select both, Control C, Control V. Control V. This is multiple selection and multiple copy. The last thing we have to do is give a value for your AC source. Our Indian frequency is 50 Hertz and our peak amplitude is 230 volt. Now change the simulation runtime to 0.02. This is the time period of a AC waveform. This is a time period for an AC cycle. This is the time period of one cycle in an AC waveform. After assigning the value, simulate it. Oh, sorry, I have forgotten to add RMS to voltage and voltage measurement. Now let us add. If you don't add RMS value, it will not give you the true value. And hence don't forget to add your RMS block. You can directly connect your scope to the voltage measurement, but you cannot connect display directly to your current measurement. To measure the value, you need RMS block, which is root mean square. Now you can see that the voltage is 169, RMS voltage is 169, the voltage drop across resistor is also 169. Now let us see the current and voltage response. To see the response, double click on your source. Now you can see that you are having two scope, that is scope across your current measurement and scope 1. Scope 1 is for your load measurement, and you can see that both are starting at time period 0. Now let us change. This is for an RC circuit. In RC circuit, in R circuit, both voltage and current are in phase. Now let us change the branch into L and let us assign some value. By this way, we will see the voltage and current relation in an inductor. Now you can see that the voltage is same. Now let us go to the display. Now I change the display. As I change the display, you can see that this is the voltage and current across an inductor for an AC source. Here the voltage starts at 0 degree, but here the current starts, the current value at 0 degree is negative maximum, but here the voltage value is 0. This is the voltage and current relationship in an inductor for an AC source. Right. The next thing is you have to see the voltage and current relationship for an capacitor. Now let us change. See, and let us assign some value and simulate it. And you can see that it will give you an error. You cannot use C separately. You have to use only RC. Give some value, assign a value for R and C, and simulate your circuit. Now you can see that it will run without any error. Now you can see that again this is the voltage and current response across capacitor, that is RC network. Now you can see that in RC network the voltage starts at 0 and the value of voltage is at 0, the magnitude is 0, but the current at 0 angle the current is positive max. That means the current is leading the voltage. The current is leading the voltage by 90 degree. Right? This is the relation between current and voltage across capacitor for an AC source. Now let us see the response for an RL circuit. Before we have seen for RC circuit, now we will see the voltage and current response for an RL circuit. Now you can see that here R is having the dominant value and hence the voltage and current are in phase. Now let us go and change the value of R. Now you can see that there is some angular difference. In before circuit both were starting at 0 because R was having, resistor was having higher value. Now inductor is having dominant value and hence you are having an angular difference between voltage and current. Now let us still next further reduce your R value to 1 and simulate your circuit. Let us see what will happen to the voltage and current waveform. Now you can see that as R value is very minimum, inductor is the dominant factor here and hence the lagging is greater and hence inductor the angular difference between voltage and current waveform will be high. Now let us go and check for an RC circuit. Change it to RC again. I am giving, in previous case RC was given 100, now I am changing it to 10. Here RC is having, capacitor is having the dominant value and hence current, the lagging nature is very high. Now let us still reduce the value of R and let us see what will happen to the response. You can see there is no change with your voltage waveform, but there is a difference. You are having a fluctuation in the current waveform of your capacitor. This is because of rapid charging and discharging of your capacitor. Right? This is the response of voltage and current across R, L and C.